Good morning, students. Today we are going to discussing about matrices. See, what is this matrix? So singular is matrix, plural is matrices. What is the matrix definition? If the complex numbers, you know what is complex numbers? See here, you know up to real numbers, yes? So you know natural numbers 1, 2, 3, 4 up to infinite, and whole numbers not with the W, natural numbers n, whole numbers starting with 0, 1, 2, 3, and integers I, R, Z. See negative numbers and positive numbers including 0, and real numbers. Before real numbers, we have rational numbers and irrational numbers. See, these rational numbers are in the form of p by q, irrational numbers not in the form of p by q. Or if you want to say in decimal form, so these are recurring numbers or terminating numbers. These are neither recurring nor terminating. The combination of these two is called real numbers. Okay. See, so we know up to real numbers only. So in this real numbers, rational numbers and irrational numbers. Rational numbers, for this rational numbers, subsets are natural numbers, whole numbers, integers. Yes. See here, complex numbers, it is not with the C. Actually, whenever you have minus 4 or minus 9 like this, so root over minus 4 or root over minus 9. So if you know the only root 4, that value becomes to 2. Very well. If you know root 9, that value becomes to 3. Why it is 2, why it is 3? You can write 4 as perfect square. Square of a number 2. So that's why it gives 2. 9 you can write as square of 3. That's why it gives 3. But can you write square of any number is minus 4? If you want to square it, negative number if you square it, it gives a positive only. So you never get again negative. So we have a problem started from here. So that's why they introduced imaginary numbers. See, this root over minus 4 you can write as root minus 4 you can write as root minus 1 into 4. Can you write like this? Root minus 1 into 4 you can write as root over minus 1 into root 4. Now this value comes to 2. But this value we don't know, root over minus 1. So that's why this one they introduced as iota. Shortly iota. So this is nothing but imaginary. So I is equal to root over minus 1 or I square is equal to minus 1. So from now, so real number system extended to complex numbers. Okay. See here, for suppose the complex numbers are in the form of a plus ib. Complex numbers are in the form of a plus ib, where a comma b are real numbers. Real numbers means 1, 2, 3, 1 by 2, 2 by 3, minus 1 by 2, minus 1 by 3, 0, and root 3, root 5, whatever maybe you can write in the place of a comma b. So this is called real part. This b is called imaginary part. Real part and imaginary part. Okay, so let us see the general form a plus ib, and expressions you can write 2 plus 3i, 4 plus 5i, 0 plus 2i, or root 2 plus I, like that you can write. See here, whenever you have 2 is a number, this 2 you can write as 2 plus 0i. 3 you can write as 3 plus 0i. Root 2 we can write as root 2 plus 0i. 0 we can write as 0 plus 0i. That means all these are real numbers. And 1 by 2 we can write as 1 by 2 plus 0i. So all these real numbers we can write as complex numbers. But all complex, for suppose 2 plus 3i, can you write as 2 or 3? No, it is not possible. So complex numbers are not real numbers, but all real numbers are complex numbers. But all complex numbers need not be real numbers. Okay, so this is the biggest set. So in these complex numbers, we can see real numbers also. So this is the complex set. So in intermediate, we can define all definitions with complex numbers whenever you want to define the definition including numbers. So we can use complex numbers also. Okay. So before 10th class, just you are going to define the definitions with only real numbers, but we can extended those definitions up to complex numbers also. Okay. If the complex numbers arranged in the rectangular form, arranged in the rectangular form, the complex numbers are arranged in the rectangular form, then that arrangement is called matrix. So what is this meaning of rectangular form? Okay, see here, first suppose if you try 2 3 5 7 2 plus 3i 5 plus 7i, so like this is in the form of rectangle. See, 2 5 7 uniformly we have, 3 7 5 plus 7 uniformly we have, so the shape will be rectangle. So mostly if you write like this, it will be very comfortable to you. Observation. So this is the rectangle. 3 5 0 8, this is also one rectangle. Okay, so like this arrangements are called matrices. Okay, first suppose if you write like this 2 5 3 8, it is not the rectangle shape. Okay, now these arrangements are enclosed with, matrices. That is nothing but arrangements here. This arrangement is nothing but matrix. Matrices are enclosed with. Closed bracket or open bracket or double lines. Take example. If you want to write not only with the complex numbers, we can write any complex number. That means you can write real numbers, negative numbers, imaginary numbers. That means real numbers means all rational forms, irrational forms we can write, and imaginary numbers. All together we can write in single matrix also, no problem. So 2 0 5 3 5 plus 2i 3i 4 5 7, like this you can write. This matrix enclosed with closed bracket. You can write with open bracket or you can fill with double lines. No problem. So this is called the matrix, and you observe. So this element where you want to write the same, below this 3 also should be uniform, 4 should be uniform, 0 5 plus 2 5, 5 3 I 7, and we should not write any commas between the numbers. Here the entries, here this is entry, all these are entries. And these entries in the matrix are called elements of the matrix or numbers of the matrix. Okay, between the elements you should not write any commas or full stops. Okay, this is fundamental. And moreover, like this 205, 3 5 plus 2 y 3, 4 5 7. These are called rows. Similarly, 2 3 4, 0 5 plus 2 I 5, 5 3 I 7. These are called columns. So, like this, horizontals, rows, verticals, columns. Okay? Just to write as a note. In the matrix, horizontal lines are called rows. Vertical lines are called columns. Okay? So very simple. Next one. If in the matrix, if in the matrix, number of rows is equal to m, number of columns is equal to n. Okay? Then the order of matrix. Order means I will explain. So the order of matrix is you call m by n. Don't write m cross n or m into n. This is m by n. You read that is the order of matrix is m by n. Okay? So you read as m by n. M by n. So number of rows is equal to m, number of columns is equal to n, then order of matrix is m by n. See example. For suppose 1, 2, 3, 4 is there. So number of rows 1, 2. So 2. Number of columns. This is also 2. You write 2 by. For suppose 1, 2, 3, 4, 5, 6. See number of rows 2. Number of columns 3. 2 by 3. For suppose 1, 2, 3. Number of rows 1, 2, 3. Number of columns only 1, 3 by 1. Generally, the order of the matrix write in the suffix of that matrix only. We can write a hero. If this is the matrix, we can write in this place 2 by 2. This order you can write here 2 by 3. This order you can write 3 by 1. Here you can write. Okay. Next concept. General form of the matrix. See here, you just remember one more thing. The matrices are denoted with capital letters A, B, C, etc. Okay. See, general form of the matrix, let us consider A is equal to Aij. So here entries are Aij of order m by n. This is the matrix A. Generally entries, if you have numbers, no problem. Otherwise, entries are denoted with small letters of alphabeticals A, B, C, D. Okay. Generally, if you want to write more letters, you write with A11, A12 like that. What is 1 I will explain. Or B, C like that. Small letters. See here, this is the matrix A. In this matrix, number of rows is equal to m, number of columns is equal to n, and the entries are denoted with Aij. Now, how to expand this matrix? This is equal to. So, how many rows we have? M rows. How many columns we have? N columns. So, this I for column, this j for this I for row, this j for column. Okay, this I for row, first one row, second one column. Clear? See here how to write. So first row I am writing now. So I replaced by 1 and j is replaced by counting numbers 1, 2, 3, 4 up to how much? N. Because of number of columns is equal to n. So you write A11 next. One fixed. First row you are writing A12, A13 and so on. How much you can write? Up to A1n. Next, second row how to write with this Aij. So second row A2 and same A21, A22, A23 and so on A2n. Next, third row A31, A32, A33